than I know myself at this point.
Yeah.
Um, all right. Well, with that, we're at the top of the hour. So yeah, there's a lot of vibing to be done this week. But 13 billion dollars is what they bought Hugging Face for Nvidia. So I guess that's quite the story.
Incredible. Yep. $13,000 million for that data.
It's I feel I feel some days like because I saw the rise of Hugging Face from my vantage point. I feel like I'm missing the boat. Does anyone else feel that sometimes? Like I don't think I
Multi-billion
am,
dollar
but
buyout.
yeah, I feel like I'm doing all the wrong things in all the wrong places at all the wrong times. But at some chronically early, I think
Or
is my
electronically early.
general. Yeah,
No, but
timing
that's
is you can have the best tech, but it doesn't matter if the timing's off.
fascinating.
How's it going, Rob?
Oh, good, 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 good. I haven't had a ton of time to experiment with Ox or as you were saying, GLM 5.3. So I'm really looking forward to hearing what your benchmarks are indicating and just how good this
Yeah.
thing is. It's and I'll just second what we were just discussing just before the preview, or just before we went live, which is the ecosystem of explainers that you're putting out at scale. Uh, yeah, that's just a fascinating part because you've got some really neat tools rolling there. So looking forward to seeing that stuff.
Yeah, it's I've been moving a little bit away like from MDs to just straight up create me an artifact. Now,
Yeah.
the issue with the artifact is going to, for private related things is going to be like data leakage and potentially being if you share something publicly, you don't necessarily want people to discover on Google kind of problem. But for a lot of the open source stuff I'm doing, who cares? It's open. So for all that, I'm creating artifacts for almost every major release. And my dream cycle now is creating artifacts that animate and describe these things that it's discovering in easy ways for me to kind of grok, right? To quick and easy sort of, information intake that's in my case targeted to how I like information displayed. But
Yes.
that creates sprawl, right? Like you mentioned this idea of Ox from the Z AI guys, and yeah, I had to like, where did I do that? Which one of my accounts is it in? Is it I've got two Claude Pro Max accounts. I've got two ChatGPT Pro whatever accounts. I've got the Grok account. I've got the Gemini Pro account. I've got a whole slew of other random shit I signed up for. It's so it's it's
How do you find it and
yes.
all that kind of stuff? That's another one too. The Grok bots. I've been experimenting with that a little bit on the side too. Excuse me. They got a lot of connectors. It's interesting what they're doing.
Yeah.
Yeah, ruuv, traffic, the proxy, the reverse proxy for web applications where you can route
Mhm.
every kind of traffic through 443 towards the application. Maybe something like that could be an improvement of what you're going to show. Like the
Yeah,
traffic portion also counts.
possibly. Well, let's dig into that. We got a lot to cover today. I want to build. I'm gonna show you guys a new approach to how I'm building, creating a harness specifically for the thing in which I'm building. And this idea, with Rooflow has always been kind of a meta harness that wraps around all these different concepts and systems that I use to develop. And then I infuse that into the development process, and it works quite well. But I've taken it a step further using my meta harness sort of tool. And what I'm doing, I'm still using Rooflow and all that, but what I'm doing is I'm creating these harnesses specifically optimized that sort of are an interplay between the CI/CD, like does it work? Do all the tests pass? Is it secure? And all these other things. But I'm also using the evolutionary capability of the harness itself as part of the process of developing the tool or the thing in which I'm trying to develop, and it infuses the harness into the development cycle, and then at the end you get this kind of amazing kind of I don't know, evolved harness that learned all the different things it needed to learn, chose different paths that said, how should I optimize based on the things I'm doing over, and these development cycles can take several days. And then it creates this kind of multi-layered harness, like the core harness that sits inside the app that I built. Then the outer harness, which is things like ruuv flow and whatever, that kind of acts as a general orchestrator. And the interplay between the two is quite interesting to watch. But the long story short, it makes these super complicated apps almost, it speeds up the development, but fixes all those kind of that 5% of the project at the end that never quite works the way you want it to work. The 5% that's 95% of the work, which it
Yes.
solves that last 5% really well, which is the hardest 5%, right? So let's jump in a little bit. Like
Awesome. Awesome.
before we get there, I want to tell you. So I did this earlier this week. So this is the Ox model from I guess it came out that it's GLM 5.3, and I've been a big fan of GLM. Actually, it's for bang for your buck. It's been the best model at 5.2 for most of the things I'm trying to do. So what I use it for is the most expensive thing you can do essentially in development, which is essentially bug fixing. And anyone that runs a bug fixing harness knows that if you're running Fable, you're spending minimum of $7 to $15 per bug if you don't want your data leaking to Anthropic, right? So if you're fixing your bugs with the Pro Max account, remember you're giving away all your intellectual property. So most businesses aren't comfortable using Pro Max, so they use the API, and that's costing you somewhere. If you're optimizing it well, you're doing $7. If you don't know what you're doing, some exponent higher than that. But in the system that I developed, I'm using a sort of escalation, right? The escalation starts at a cheap model. There is no cheaper model than one that's free. Now, the drawback to this stealth mode model was that it was very heavily rate constrained. But don't worry about that. My harness handles failure really well, so I was able to do quite a bit of testing. It just took a little bit longer than I would have hoped. So it took like 20 hours versus if I was using a paid model, would have taken like 20 minutes. And those are real numbers, by the way. All right, so what I did is I created and all the code you're going to see here is available. It's on my MetaHarness repo. So I created a test you can pass but never study for. And remember, the pass but you can never study for is really important. If you use an oracle in the structure of any benchmark, you're inherently cheating, right? The benchmarks are essentially asking, what do you know based on the corpus of information you were trained on, and can you answer and solve a problem purely based on reasoning and that sort of recall of that trained information? Now, if you start giving it the answers because you've done the tests before or done similar things before, that voids it. And so a lot of the early sort of benchmarks you saw people making these big giant claims on, they were almost always using an oracle and then saying like I beat the state of the art by some crazy amount, and then it comes out a day or two later that they used an oracle. So this is the part that says I didn't use an oracle. I'm still using SWE Bench, and I probably shouldn't be. I also ran this against the Arc 3, and I get 100% on that, but I was already getting 100% on that. But that's something I'm going to discuss here in a minute based on some work that NVIDIA was doing. So I'm looking at like, how does this compare? So DeepSeek is kind of my tier 2 escalator. So I previously had gone from GLM 5.2. If it failed and it couldn't answer the problem for whatever reason, then I'd escalate to DeepSeek. The two of those would answer somewhere in the realm of 85 to 90% of the problems at a 56x reduction over the cost of something like Fable. Now, if those first two tiers fail, then I can escalate. And now the escalation uses every step uses a router. So the router remembers essentially what the optimal LLM is for given problems. So then I can use something like an open router or requesty, and I can then route to things like the ChatGPT model if I need certain problems there solved, or I can go to Claude or other models. Now, the key in the decision at that point is which is the model that's going to give me the most bang for my buck, the highest intelligence at the lowest cost. So it's routing for the Pareto frontier. Pareto, I guess it's Greek. I don't know. Pareto. Anyway, the lowest cost frontier is what that's called. So I've already did this, and that's the sort of structure of what I was doing previously with the harness. So I'm using complicated hard bugs to test against. And what we're seeing here is the number of patches produced, right? So we see here that DeepSeek produced 53 patches out of 100. Alpha did 19 patches, and Claude did 42. Now this is volume, right? This is a volume play. This doesn't speak to specifically, what's good or what's bad. It just says how many patches, successful patches they created. So Ox goes quietly on roughly 4 in 5 tasks, meaning it's smart enough to say, I just don't know. I can't solve that problem. It simply returns nothing on many file problems on tasks that it does not take on, though something unusual is about to happen. So what that means is they created some form of agentic process in the front of the model that essentially says, I just can't do it, which is perfect. I don't want a model to chug away 53 times to get to the answer. That's expensive, creates churn. I just want to get to, nope, can't do it, moving on to the next one. And that's exactly what they did in the front of this model, which is what makes it so valuable. Because even though it's slow and cumbersome, just the fact that I can get a response saying I can't do it is actually pretty good. So the next thing is how many bugs actually got fixed. So the other is talking about churn, and churn speaks to cost and time. Now the next one is, can you actually solve these problems? And now Docker judges applied each patch and runs the seal test. Green means the bug is generally fixed. This is the only score that really matters or counts to me. Now, the free model more than doubles the budget model, DeepSeek, which was not even my budget model. It was like my top tier mid model. So 13 versus 6, while writing a third as many patches. Claude leads at 29, but the real story is hiding in the ratio. That is the key here. So just think about that. The free model, which used to be my crappiest entry-level model with no real harness other than me, at making the request, is able to get 13 out of 10, even on the free sort of rate limited version. So what does that mean? Well, Ox or GPL 5.3 or whatever you want to call it is a sniper, and that's where the part that's important. It doesn't take the shot unless it knows it can get the job done, right? That is important. So it divides fixes by attempts and gets the patch precision. When a model does a commit a patch, how often is it right? Suddenly the free stealth model isn't budget class at all. It's shooting at nearly frontier accuracy. So this is the important part. So DeepSeek, in this case, like 6x lower than OX Alpha on 13 and 19 patches hell, right? So OX lands 68% of the patches and it writes statistically on level with Claude 69 and 6 times that of the DeepSeek model. So we're talking about a Chinese model that is comfortably on par with the Fable models at a fraction of the cost. Like it's not going to be free, obviously, but currently GLM 5.2 is by far the cheapest model at a fraction of the cost of DeepSeek. So high precision, low recall, a model that says little but means it. The profile near frontier patch quality paired with blank answers on big prompts looks like less like a weak model and more like a strong one behind a cautious serving config. That's key. There's some form of something in front of this model that basically says, I'm not going to answer that for you. I can't answer that for you. And that's good because I can get to that quickly. Now, is it doing that because it's like limited in the same way Fable was kind of, butchered a little bit because it's too freaking strong? Probably, which is exciting. I can't wait to see what happens when they take those away. So free and blunt ties, cheap and elaborate. Early this week, DeepSeek in a full governed agentic loop, inspect, edit, run, test, retry, up to 20 steps per task. The scaffolding lifted it from 6 to 13 fixes. OX reached the same 13 in a single shot. Single shot versus having to do a evolutionary harness on it. But that says two things. Remember, says that the meta harness is definitely as important as training, if not more. So I was able to do an agentic loop and basically double the performance of DeepSeek just by using the sort of Darwinist meta harness approach that I'm taking. So that's a great validation as well. But a better model thinking once matches a cheaper model running at the entire harness. The model was bigger lever all along. So that means that the model is not dead. We haven't reached a sort of wall yet, and the sort of combination of the harness with a more capable model really makes a huge difference. So the scoreboard, the verdict, if you will. Now, again, I don't know what the final price is. It's not going to be free, but all one shot on the same sealed 100 tasks, all graded by the same Docker judge. So I've got base model, no oracles, same judge, same structure, same request. And by far, in my opinion, Ox wins. Ox Alpha fixed more than double what the budget models managed at zero cost. Obviously, the zero cost is secondary. Its 68% precision is statistically on level with frontier models, and the model harness one shot beats cheap agentic. So basically, we're in a good spot there. That's that was my analysis of Ox. I don't know if anyone else has looked at it. Yeah, it's slow. There. What do you think? That was my you know crash on that. Anyone else play with that model at all? Or I'm in the weeds here.
Yeah, I
Yeah,
did. I
great
probably.
reads. Go ahead. Sorry, go ahead.
Oh, I didn't say anything. I was taking a breather.
No, there was someone else there that just spoke up. Please feel free.
Yeah, it was me. I played with it a bit. I had less luck with it, I guess. But I'm just looking at it now, and it's the flash version of it is out and will run on. I put the stats in the side there, but there's some unsloth quants out, so you can get that running locally. So the flash one is looking pretty good based on that. Let me just see if I can find where's the yeah. So that's talking about the dynamic 4-bit quant running. So that's 200 gigabytes and 93% accurate of the accuracy of the full one. It's the flash one, so it might not be. Your mileage will vary. I don't think there's so many results out on that yet, but that's looking optimistic. This is Frontier class you can run at home.
Yeah,
Mm.
we're living, and not only can you run at home, now that I've got the ability to separate each of the experts in the model, we can run this on a phone. We can run this on edge devices. We don't need to run the whole damn model, right? We just need to understand which parts of the model are most efficient, effective for the things that we need it to do. Then we can fine tune those parts. And so what we're seeing is this kind of separation of these really capable models, and we can kind of mix and match them and take the bits from the DeepSeek that we like, especially for things that where we get weights. We can really create kind of model mashups, which is
I'd
the
love
most
to see
exciting
more on
part.
how you're isolating those bits out, actually, because I think I've
Yeah.
missed a couple of times that you've talked about it, and I think
All right.
it's super super powerful, and obviously I really want to do that, but I think I've missed too much.
Yeah, so I've got it's all in my meta harness. Let me show you guys. So a few weeks ago, I did that for the Kimi K3, which at the time was the state of the art. It isn't any longer. But essentially, what the Kimi K3 harness does, this harness essentially allows me to separate the parts of a just absolutely massive parameter model, almost 3 trillion parameters. So there is no way I'm running that in anything that I can afford. You're looking at like probably at least one H100 run, chugging away to get that thing done, and or something of that caliber anyway. So let's just say minimum $50,000 machine or more. And I don't, I'm a startup. I don't have a $50,000 machine laying around. So what I needed to do is separate the parts of the actual system that allowed me to basically take the internals of that particular model and then essentially reassemble them. So that allows me to, where did I put that? Kernel nappy, too much stuff. That's why I do ADRs. Let's go to my ADRs so I can figure out what the heck I did there. There's only so much room in my brain. All right, so ADR 40, maybe that's evident. 48 might be the one. 48 formal. This is formal proof. Geez, I create a lot of stuff. Um, it keeps going and going. Everything I've ever done is in ADR. Okay, we're gonna go to the end. All right. Okay, I went too far. Looking for, you can see I did this is the AGI 3 bench I did. We've got host prime, turn credit. I don't know. This might be a question for ChatGPT or Claude, but essentially there was a C library that came out. The C library that was an example of how to sort of separate the parts of K3. I re-implemented it in Rust because that's what I do, and then I created a essentially a harness around it to do that for other models and sort of dissect them. And so that's was a few weeks ago. I'll have to ask Claude exactly where that code is and how I can implement it. Yeah, I've been struggling with sprawl. I've got like with so much output, it's hard to remember where and what and how. A few key things I did this week. The latent mesh stuff that I've been messing around with, really interesting. So for those who don't remember, was it last week, 2 weeks ago? I created something called latent mesh. So latent mesh essentially allows me to play with the various parts of the inside of a language model. Once I separate the language model, first of all, then I realized that inside of the language model there was a communication pattern that was independent of the token output of the model itself. So it uses a kind of latent space description that describes intent. And it does that in the most basic structure. So think of like the most basic way to describe the delta between what it is and what it needs to be, where it's going and where it should end, as a kind of vector style description of a problem. It's a latent communication structure, right? And it's hard to really describe where normal networking uses the idea of things like packet information and a steady stream of information to represent the information flowing to and from. So think of like the output of a language model that uses tokens, right? The stream of that language model as an output is words and spaces and information. If it's a music one, it might be songs or whatever, but it's basically information and it's a constant stream of information. Now, what happens inside the language model is it doesn't use that streaming sort of approach that we use for sort of communicating information over an extended period. It uses this delta, the difference essentially, and then describes that. So once I realized that, I could do two things. I could take that information that exists as a delta because it's super light and super strong and capable of being reassembled into much greater things, and I could use that as a basis of a communication channel. Now, what was interesting about that communication channel, I got to find my latent mesh, is once I was able to do that, I was able to then communicate that through again a network, and that is a much lighter. So rather than sending 20 megabytes of streaming information, text, and whatever over an extended period, I could encapsulate all those 20 megabytes or whatever the number is, a huge amount of information into a bite-sized delta, a vector of what that. So think of an embedding. Yeah, that's exactly what it is. It's an embedding. So I'm communicating the embedding as a network artifact that I can send to different agents, to different systems, to different communication, and I can do that at a fraction of the amount of network usage. Now that I did that, I'm now able to have the language models or the different parts of the language models communicate with other language models that are afar. So rather than having the language model all sitting locally on a single machine and having a kind of monolithic GPU trying to figure out all the answers across all the different parts, I'm now able to separate each one of those parts and have them communicate over a long distance that allows them to stay in synchronization with them as an eventual consistency. Turns out the tool I created like a year ago around the Quick protocol, which uses the UDP protocol versus TCP, works perfect because one, it doesn't require a handshake. Two, it uses eventual consistency, meaning I don't need all the information to arrive at the same time for the information to be meaningful to both parties. And three, if the signal is lost for whatever reason, your website goes down, there's a hiccup in your Wi-Fi, whatever, it can then reestablish itself at some unknown point in the future, whether it's a millisecond or 10 days from now, makes no difference. So it's the optimal mechanism for sort of a communication pattern between things. Now that I have that, I now have the ability to then define that through a system that is capable of you know relaying that information. So I took it a step further. So I created something called air. Now this is where it gets absolutely bonkers. So the air, let me see if I can find an explanation of that. Where did I put that? Mesh air. Okay. Okay, so hopefully you follow what I'm saying. I found what the internal dialogue of LLM is using this kind of communication, embedding system. It's super light. It's thousands of times less information to portray the same amount of information based on intent versus packets of the actual information. So then once I had that, I'm like, how can I deliver that? Now that I've been able to take something that used to be megabytes and brought it down to bytes, what existing communication systems exist in the world that are based on bytes and things that are less than a kilobyte? Well, turns out there's something called shortwave radio. There's in VHF and even uplinks to 1970s era satellites all use really low bandwidth radio waves. And there's a whole spectrum of things in the range of like I think it was like 14 millihertz or something like that are open for people to use, and they go crazy distances. At my cottage, I can reflect an RF signal off whoever owned my cottage before me on Lake Huron was apparently a radio buff, and he had a VHF tower he built that goes up probably a good 30 meters, 50 meters in the air. So I got my son to climb up to the top of that and put a transceiver on it. I can bounce signals off Lake Huron, the second largest body of water on the planet, or freshwater, and I can bounce signals thousands of kilometers off the lake in any which direction I'm beamforming that data. But the drawback of that is I can only do it in a kind of messy and low fidelity way, meaning I can only send like limited amounts of information. But using this idea of a latent mesh, the UDP or quick protocol that assumes eventual consistency, I'm able to then create an ad hoc communication system capable of broadcasting these signals all the way to California from Ontario and potentially all the way to Ireland and maybe even with the right winds and atmospheric pressure all the way to places like Europe, like along the coast of Western Europe. And that means you can bypass the entire need for using, traditional communication systems like the internet itself, or taking it a step further, if you have permission, you can bounce these off satellites. Now you can if you get permission, don't hack a satellite. It's highly illegal. But assuming you get permission, you can there's a whole constellation of 1970s and 1980s era satellites that are unencrypted and only require the right handshake on the right RF frequency, which is specific for that satellite, which just so happens to be all defined on the internet, and you can actually start rebroadcasting using that satellite, sending that signal again to another part of the world in that particular frequency. So at this point, you basically are capable, hypothetically, of bootstrapping your own Starlink network on super low bandwidth. But for the types of things that we're broadcasting, we don't need to we no longer are constrained by a continual stream of information. All we need is the unique, deltas that are bite-sized and infrequent sent, and that can create a multitude of sort of communications around the globe without having all the information sent. Now, think of what that means in a more practical terms. Think of the ability to, rather than have to send a bunch of video of a location, you could potentially map the location based on radio signals and audible signals that are capable of being picked up in the local environment, and then send the delta to the cloud, or it's not cloud, to the constellation. Now, the benefits to things like video and audio and text, AI, is we can pretty confidently recreate those environments with basically a kind of AI inference of that environment to a pretty high fidelity. So you're essentially faking real-time video without having to send a pixel of real-time video. Your ability to hear without actually hearing, the ability to see without actually seeing, becomes nothing more than a delta that's being sent from some low-end receiver capable of receiving that information and then transmitting it. Now, if that's not crazy enough, and I'm sure it's crazy, we can take that further. And this is something that Ofer was suggesting the other day. Uh, well, what if we could see with sound, right? It doesn't take a lot of power. Everything ricochets. So oh, so we took that. So I took this step further. So Oprah's like, yeah, you should do BatView, right? I can create a sonar system with nothing more than my phone. And this was, well, I think it was on Tuesday. He just randomly said it. So I'm like, all right, let's see where that takes us. So essentially, the phone can emit, it has two things that are really powerful, and these are things that you wouldn't even think are really powerful. It's got a speaker and a microphone. So this turns out if you know my kids were doing this thing on the phone the other day where it was like this weird pulse, and apparently I'm too old to hear it, and so that got me thinking like. Okay, there's this. I guess because I'm old, my ears don't work so great. I've got, there's this frequency just above what humans can hear, which you guys might remember my ultrasonic project from last year. What if I could make that into a form of sonar on your phone and map the spatial dimensions of a room based on that, kind of like you would using LiDAR? So that's what I set to do. But what I did in this particular process is I used a harness as the sort of structure of how I actually built it. So I'm going to jump around a little bit, and I hope this isn't too disjointed for you guys. But I want to know which Claude account did I use? Who knows? But I just did this in Claude Web, I think. And where did I put that? I just want to iPhone room. Did I think this was the one? Yeah, this is it. All right. What I want to show you is how easy it was to build this. All right. Why isn't that scrolling to the top? They needed like a home option for these long-winded. This ran for hours. Like I think it ran for about 12 hours. But all right, keep going, keep going. The, ho the home button doesn't take you home anymore. That all right, this is it. Okay. This is the prompt. This is the part. Now keep in mind I've got skills and all these things built in so it knows about ruuv flow and everything. So you're gonna have to install that. But I'm gonna show you generally how I got this, how I built it. So we've got, this is, over just telling me an idea. So I know we've got ultrasonic, right? This is my ultrasonic project I did a while back. Now the ultrasonic system was essentially the platform that allowed me to basically hide agentic communications in the 18 kilohertz. Start with some shit.
Yeah.
Now back to this, or where I got lost my place. Okay. Now what we did is so refer to that just to get the general idea of how I like to do stuff, and by while you're at it, fix any problems you discover in that repo. Always for me, because I've got so many repos at this point, it's always like fix what you find and push it upstream and publish while you're doing the other development. Now, but the important part here is you says uses various RuuVnet tools. Obviously, I'm very proud of my 100% self-contained ecosystem at this point. I don't use any dependencies on anybody else's stuff other than my own stuff, which is crazy. But anyway, so use a meta harness, use Flywheel, and use Horizon packages. Now, the Horizon package is particularly important here. What the Horizon package does is it provides, well, let's see what I described here. A portable deterministic core of Google's ADK's long horizon harness. Now, this was a harness that Google came out with a few weeks ago that basically works particularly well at, building things over an extended period, like days, weeks, months, years kind of thing. So I like it. I want to give it a spin kind of thing. And so this is going to give me the ability to, have a high-speed implementation of that sort of harness idea. So back to my original discussion earlier, I was talking about infusing the harness into the development. This is what I used to infuse a kind of long horizon driver, and provide a kind of ability for it to stay and infuse and get better and use all the other tools that are related within this environment, like Flywheel and stuff like that. The other part that also made a major difference this week, while I'm just rambling here, is AVO. This was a project that took what Google did and basically did their own spin on it from NVIDIA, and they claimed to get 100% Arc 3. I already had 100% Arc 3. I guess I should have maybe done a press release or something. But so they were able to do essentially what I was able to do, and AVO did a few things differently than I did. So I essentially adopted all the things that I didn't do. I took their bits and infused it into my bits, and we have a meta harness love baby here. And so all that goes into the system. So it's always learning. And remember, anytime I push an update to meta harness, it flows into other systems that use meta harness, namely ruuv flow. So ruuv flow, just by osmosis, is getting smarter and more capable as it kind of does its thing. All right, so I gave it a prompt, said it, told to use harness. Harness is kind of the jump off point, include GitHub submodules, and this is because I want to kind of include the upstream. And then I created a new repo called BatView. Now we go, it's doing its thing. Again, this ran for, I don't know, I think it was like 8 or 12 hours or something. And it's just running. Now, at a certain point, I probably went to bed, and you'll probably see that I made a comment like, keep going while I sleep or something. I don't know. But it kept going, 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 doing its thing. Now, going all the way to the end. I know I have to scroll now to the end. All right, that's a lot of information. All right. Now, at the very end, what I did, and this is, when you see my presentations, we'll go up to where I wrote the prompt. Keep going. I gotta find it. Okay, let's see. I think I said scroll. No, it's too much stuff. They haven't made their UI particularly user friendly. But the way that I'm doing these UIs, let's go back to here. Notice how I scroll. It animates in, and the phone has two halves of bat, and then you can see as I scroll it animates. This is a style presentation called Scrolly Teller, right? And my AI apparently knows I like Scrolly Teller. I like this kind of, cinematic sort of style. I like animations and 3D and sort of stuff. So it created this at the end of the development, which ran for 12 hours, to illustrate exactly what it had built and how it worked. But not only did it do that, when you go to the repo itself, check this out. And this is me. This is totally on autopilot, I might add. You saw I did like one prompt, and so we go down here. Not only has it done it. Oh, it did an iPhone version of the app because it knows now that I like iPhones. I'm gonna get to that part of the demo here in a few minutes, but it also created the screenshot of the hero and slapped it in the page just to make it look a little better because it knows I like that, right? It's now knows that ruuv flow has a image at the top and people like to click it. I never even told it to do that, right? It just kind of instinctively knows what I like. And when you go to my different projects, you're seeing that now. Well, yeah, here, Latent mesh as well. Right, and this one created an explainer as well. What the heck is latent mesh? Now this one was a little more out there. I'm struggling to exactly describe it, but you can see that it went ahead and created an explainer. It published it to my GitHub pages, so I don't have to worry about remembering where the artifact is. It's got the stats I like. This one's not quite as animated as the other ones, I guess. Maybe it's learned that I like more animations, but it's still not bad either. You can see, how it's learning what the ADRs represent. So it's a great, this is a lot more compelling than a, MD file, which is pretty cool. All right. So, actually, let me pause for a moment. How am I doing? Are we in crazy land yet? I just
It's
described.
spectacular.
Let's recap for a moment.
Yeah.
How to bounce radio waves off Lake Huron across the continent? Don't hack 1970s era satellites, and create your own Elon Musk Skylink. Yeah, and everything in between. But the harness is definitely the thing. What can I say?
Yeah, spectacular. And that's it. I mean, the combination of recursion and stacking of all the components and the outer loop awareness boy, you can see how it's accelerating on
Now,
full display now.
so I'm on a roll here, guys, and I'm building a ton of stuff. I want to show you. I'm going to show a few more things, unless you guys have questions. I'm happy to answer a few questions before I jump into how I'm building an iPhone, an iPad, and Android app all at the same time, and an Apple Watch app since Friday.
One question. You are coding so many different projects, and what I noticed, because I'm using Codex more or less, and not your meta harness so far, that a lot of stuff gets implemented rudimentary, and then you need to do a lot of iterations to get it fully developed, to get it bug-free. I'm having like edge case testing, I'm having like friction reduction testing, and stuff like that. How do you get all those kind of, let's say, different dimensions fixed in one go? Because for me, it's like an iteration. I have like 1,200 issues, let's say 1,000 issues for my ICP project, and they're not getting less, they're getting more. So
Yes.
I wonder myself how you handle it.
Yeah, let me show you. All right, so I've got a nightly dream machine that runs across my entire portfolio, and I'm much like you. I'm throwing stuff out there, and it's half baked. And the problem with half baked is, Reddit loves to pick on me, and I don't, I guess I got a thick enough skin, but I want to make it as good as I possibly can. And eventually, things need to cook for a while longer, often after I put out the random things I'm building. So this is a private repo that I have called Core Memory. So inside of all the different services I use, whether it's Gemini or whether it's ChatGPT, Claude, Grok, whatever, I always tell it to use my core memory as a core federation to check and coordinate with all the other systems that might happen to be running. Now, I like using GitHub because it creates a kind of graph structure inherently with commits and PRs and branches and stuff. So I'm just letting it basically say, use this environment and figure in and kind of coordinate yourself and get better over time as best you can. So this is using a URI structure. Turned out the URI structure is actually quite a bit better than MCP and other things. So what the URI structure does in this case is ruuv. So in my little network of agents running all over the world and all in different ways, it now has its own ruuv subnet. So think of like the dark net for ruuv, if you will. And so ruuv dot dot slash is a structure that uses the RVM and RVF format as the form of package, network interoperability, the latent mesh, and all those sort of pieces now have a common structure to indicate who they are, where they are, what they want, and so on and so forth, rather than an arbitrary sort of data structure that gets invented for MCPs and uses this idea of sort of traditional TCP based communications, which requires streaming and doesn't handle fault tolerance and all that sort of stuff. So now I've got my own little private version of the internet optimized just for ruuv and to optimize against everything that I've ever created on an ongoing loop. So when you go into, for example, the PRs, in this case, this is a private repo, unfortunately, but when we go into the PRs, we can see different things that it's doing, different PRs that it's pulling, different issues that it's defining. So we can see here like a federation record, for example, and now shared invariance. These are just things it's learning about. Now I'm getting morning reports in the case of ChatGPT across all the things that it's learning. So let me find an example. Here it is. Okay, I'm going to switch to my Mac for a moment. And one sec, and then you'll get a little sneak peek of my desktop or my iPhone app. Okay, so this is last night's dream sequence. Let me close this one sec. Okay, so the dream sequence essentially again is running across my entire portfolio of things, and we're talking hundreds of repos and I don't know 100 million lines of code, some ridiculously large number of code that I don't even know it's so big. It's ungrokkable by my brain. So what this does is it goes and every night it goes and runs these different reports. So let's go to the end here and see if we can find today's. So yeah, here we are. This is today's, but I actually look forward to seeing this every morning. So where's the start of today's? Here it is. Oops. Yeah, we'll start here. Okay.
Um,
So inventory.
just to
Yeah,
understand correctly, so you created your own inside network that acts as the resources, and you have recurring jobs that iterate over your whole repository ecosystem, not only a single repository. So is this correctly understood what you're trying to explain?
correct.
Okay.
Correct. Yeah. So it's examining all my things and creating it's asking things like, one, if this project is more than a year old, is there a security problem with it? And it's found things, obviously. I was vibing 3 years ago. And so it goes and first of all fixes the security problems. Those are the highest priority problems. Now it says, okay, now that I've fixed the problem, does everything actually work? You know, yeah, to your point, this was a problem, big problem years ago, right? Where you create stuff and half the stuff didn't work. Make it work. So anyone going into my project from 3 years ago gets something that's functional. And lastly, since you're already there, what's the state of the art for the thing in which I built 3 years ago? And can you implement the state of the art for that thing? Which is crazy because it does every time. But I'm not saying go do it. Only do the state of the art if there's something else that's doesn't take precedence or whatever. So there's like a hierarchy of needs. So the system now is working through the different issues. It found issues relating to my world graph or root vector or whatever. It found here the ruuv bat PR executes a frozen valuation state. This is a perfect example of I pushed something, and after I pushed, it needed some more fixes. And I historically I had I was like I build it, set it free and forget about it, which led to things like the early days of review where it was like, it's slop, it doesn't work, blah, blah, blah. Well, it worked for me. I just didn't spend any time making it work for anyone else. And that isn't necessarily the best answer to problems, right? So that solves that problem, in which from my broad portfolio of stuff was a recurring issue. So you can see latent mesh. So it's looking at the newest things and it keeps going. Each of these are nightly dream cycles.
Mm.
So you can see, and now I've also got a soda cycle. So these, how do I close this? I don't want that. There
But
we go.
how do you connect the stuff that gets scheduled in OpenAI's ChatGPT, which I know, or maybe even in Claude
Oh,
and
it's
environment,
just
and then make
it's
it trigger stuff?
Yeah, so this is what it looks like. So I've got my MCPs and other tools integrated into ChatGPT or Claude. I do the same thing, Claude, but lately Codex has just been better, just for most things. And in this case, I'm acting as ruuv's long horizon research, right? And it goes into details of how it needs to research, the tools that I want it to use. Remember, ChatGPT now can run in the cloud or whatever they have, running these things. So I'm telling it that it needs to use the tools that I like to use. So it assembles those pieces in interesting and novel ways. But I know, that, I explained to you why the latent mesh is important, what the dream machine does, and ruuv field for spatial awareness. So it knows all the tools that I like to use. And then we go further, reject, like, I don't want you to do everything. Rejection is important. Incremental or marketing driven work unless it materially improves ruuv. Now, that's and I spelt ruuv this way because ruuv this way in my brain is the ruuv AI. It's the ruuv brain, where ruuv with the capital U is me, and I need to make the distinction in my systems between what I built and what's being built for me. So, and I know I might sound like a maniac, but the spelling ruuv this way is a marker of sorts that indicates that it came from one of these processes. So when I see it, I instantly know, okay, it came from my dream machine or some recurring process. Prioritization. So the prioritization means, like, you need to weight this stuff. You need to create a rubric to understand what's important from what isn't. And this is particularly important in long horizon. And it directly gets integrated into the harnesses that are being created for these things every night. And remember, these harnesses are self-improving every single night. They're not just saying, what bug should I fix, but how can I fix myself to make this sort of thing better, more capable over an extended period of time. So the prioritization is a key factor of, like, how it understands near-term, mid-term, long-term value and potentially obsolescence. Execution. for selected ADRs, this is how I want you to work, and for scopes and budgets and capacity and this sort and this, that, and the other thing. Benchmark must remain baseline. Like, I don't want bullshit benchmarks. As you guys know, I've suffered through a few of those over the years, and I don't want that to happen again. So that is my anti-bullshit benchmark paragraph. I've pretty much learned every bad lesson by doing it, unfortunately. Output and governance. You know what I'm going to do for you guys? I'm going to copy and paste this whole thing. And I'm going to put it, let's go into Brave. All right. We're going to go to my gist. GitHub. And what's up with the GitHub actions lately? Like, anyway, GitHub sucks. Get your shit together. All right. So we're going to go in here and we're going to call this, I'm going to call it ruuv soda researcher. It's not really a researcher. What am I going to call this?
So while you're doing that, so you literally have those scheduled jobs in ChatGPT, then they have a certain priority to iterate through all that is available and what might need to be done, and then it gets distilled, and then it triggers via MCP your different harnesses and different let's say maintenance tools which you probably built to address that, and then it starts working on them step or piece by piece.
Pretty much.
Okay. Yeah, then I think I got it.
All right. So the last piece, you guys can grab this if you want. Just modify it, whatever. Now, you might need to, it'll figure it out, but you might want to mention RuuVnet if your AI isn't, familiar, if you will. All right. So last part. I'm using all this stuff. I'm building them, and everyone in the RuuV world always tells me it's really freaking hard to, get RuuV configured. So I've been building a RuuV, there we go, RuuV mobile apps. I'm gonna show you what that looks like. So I'll show you the phone one. It's probably bigger. All right. So what this is going to do. So first of all, for the RuuV fans out there, C6, you got to use it. S3 sucks. And what made me really realize that the S3 sucks is this very app that I'm building, because suddenly I had the ability to do real-time calibration to optimize my deployment of the RuuV system. Yes, it seemed, before I was kind of moving things around, placing it in certain ways, and kind of hoping for the best. This just makes it visual and easier to understand while doing it. So what I'm doing is I'm creating an app that essentially allows you to go and discover and do all these sorts of things, like set up your sensor fusions, your vital signs, your rooms, and everything. And I'll show you what I built so far. And this has been building, keep in mind, since Friday night. So this is roughly a week's worth of automated development using the codecs, and I'll show you some of that here in a minute. Codecs for Mac that controls your desktop, and using Xcode and a few other things, and my iPad that's connected to the computer right now. So in this case, we can go to calibration. Now, the calibration, remember, every room needs to be calibrated. And a lot of people just plug in their ESP32s, put some firmware on it, and say, it doesn't work, this is slop. Well, no, you didn't calibrate it. And the problem is, there's this tug of war between, Claude and ChatGPT and the stuff that I'd make and what it believes based on training and stuff they got from like Reddit saying it doesn't work, based on like, just look at the damn code, it works kind of thing. So what this does is essentially helps you through that phase. So choose the room. I can change the room. You can set the dimensions. I'll do American inches or yards or whatever crazy shit that use in the rest and in US at some point. But for now, I did meters because meters are just easier to work with. I'll add that to the settings. Several people have mentioned that they don't know what a meter is, which I find odd. But regardless, we can go in here. We can place the ESP32s. So what this is doing, so I've got 4 running currently. And we're looking, I can see real-time view of the signals. Lower signal is generally better than a higher signal. And when it's green, it means it's placed in the right location in the room. But where's the right location in the room, right? Well, I've got an answer for you. I've got the ability now to as you hold your phone, you can place the ESP32 in different parts of the room. And what that's going to do is tell you exactly, kind of like bing, bing, bing. You put it in the right spot at the optimal direction. Maybe you might need to add an antenna or whatever it is, and this will guide you through sort of the placement. You can define whether it's where the Wi-Fi router goes, if you've got a router in the room or your laptop, and you can optimize and learn the structure. You can define, different characteristics of what the node is. Like it's my node one. It's kind of the main, hub or whatever. It's a base station. It's a receiver. I can use my phone to determine this location. It's spatial location, 30 centimeters from the wall. Now I'm also using Over's BatView to do pings of the wall so I can determine the distance and the characteristics. I can use, if you've got an iPhone Pro version 12 or above, I can use LiDAR. And the LiDAR can do a spatial map of the room that fuses along with the CSI and the sonar and the other crazy stuff that I might have attached and collected into the environment. So it's helping you through the entire process. Then it's going to train a quick trial. So it's like, is this optimal? So I'm not training the entire model. I'm only training a 12-second trial. But then what you can do is you can then figure out how to sort of optimize your environment, for overnight. So if you want a baseline when no one's in your office, or maybe you want different kinds of baselines, it'll help you through that. I've integrated the cognitive meta LLM system. That's basically a kind of cloud hosted version of all the stuff I just showed you. So everything I showed you is available through an API in Cognitive, flywheels and self-learning and escalation and all the other things. So I'm using that. And if you want help, you can feed it back to the placement coach, and it's going to analyze your spatial environment and help you through the process of how and where and what to place your particular system. Now, right now, I'm in the middle of developing it, so I'll have to show you that in more detail next time. But that'll be a key part of the equation. Then we've got this idea of record an empty room, and this is a part a lot of people sort of skip. Remember, I use the approach of contrastive AI. Contrastive AI is basically what's the normal baseline, what does empty, what does the void look like? This is training the system to understand what the void is, right? Based on different types of voids, your room being a void. And then when you go into your room and you have two heartbeats, okay, that's my wife and that's me. Oh, well, there's a third heartbeat that's beating kind of strangely. Oh, that's my dog, right? And you can describe the system in terms of the characteristics of the environment, but more importantly, you can describe the system not only in characteristics of the environment, but characteristics of the adjacent environment that you need to ignore. So think about like when you're doing a Google search for something and you're looking for, I don't know, pools, but I want pools, but I only want pools that involve pools of blood. Well, then you're going to do negative water, right? And that's going to help you search for things that don't involve pools in your backyard or puddles, right? So similarly, we can describe what needs to be, ignored. In this case, ignore the dog at the foot of the bed. He's cute, but he's not that important for me to sort of monitor overnight, right? So it's a contrastive. So this is going to help you train the motion coach to understand your environment. And what's cool about this, I'm using the GPU on the iPhone. So you don't need it. You can do this anywhere. Now you can use your desktop or whatever you want to as well. But I'm basically using the AL capabilities in the most recent phones to do that. So if you've got an iPhone 16 or above, I'm literally training a model using it. It gets a little hot, which is weird. But other than that, and then it gives you yeah.
When you say empty room, because Wi-Fi travels also through walls, so does empty room is just a single room with the sensor, or should I evacuate the house or the building?
No, I've been unable to evacuate my house. And the biggest challenge I have in my house is, I got teenagers and there's always something going on at almost all hours of the day and night. So by subtracting, so in this case, Isla, who's in the office or the bedroom next door, she's on her phone. I need to ignore her heartbeat because she's adjacent wall, and I can pick up her heartbeat, and her heartbeat mixes with my heartbeat, which is beautiful as an analogy, but not particularly great in terms of monitoring me. So I needed to describe that in a way that was, as a negative value to what needs to be analyzed. That's
But
what this.
how would you handle it in the calibration phase or the training phase?
So I've got a structure that allows me to describe those characteristics as part of the environment. Now I haven't shown that because I'm still in the midst of developing it, but basically as part of this process, I'm going to have a button probably somewhere around here that describes the negative. I don't know really how to describe it. The negative value of some of the environment, and in this case, I can paint the zone. So we can go in here and we can create these topologies. So this is me sitting at my desk right now. As you can see, kind of I'm moving around or whatever. But I can also describe that in more detail. So in this case, I can go to my topology and I can describe, what that topology looks like in different, in its structures. So I probably need to change where I put these buttons. I'm going to move those above, I think. But if I want to see it from an orbit point of view, I can change it up. If I want to say there's someone next door, I can go to my build mode. The build mode will essentially allow me to add those kind of items in that environment and describe where and how that environment works. And if it's picked up upon outside of, let's say, a certain range, then the system's smart enough to indicate, well, it's beyond the known range of that room, therefore it's not something we need to pay attention to. It's someone walking outside of my store, it's my daughter on her iPhone, whatever, and it only needs to be held within the boundaries of the spatial environment. That's what this UI is intended to do. Now I can also do that, on your phones, it's a little wonky, so I can go here and I can do that on an iPad or whatever I make this app, available for, and it's just, a similar but better experience kind of thing.
Yeah, I got you. But that's not currently in your review. This future development
It's all,
is going
yeah,
to happen.
it's all, if you know how to assemble it, it's there. But, I've given you like the Lego building blocks, but I haven't given you all the instructions to the Lego building blocks. And so what I'm intending to do here with this app is to take it from, science experiment to something that's feasible and functional with like a couple clicks. So if you want to go in here and you want to do, dense pose, which everybody wants to do, and you want to look like Superman or whatever, in this case, one click and you'll have the environment. And now for this, I'm going to use LiDAR, most likely. LiDAR and maybe camera and a few other things. And it's boom, you've got the ability to instantly transform your environment and see through, whatever, and have it more visually, compelling. Now in other cases, I might want to do vitals, health. So you can click it, you can open verified demo. You can see the stats. Now I've got a whole, and for the sort of power users, because I love to explore the most crazy parts of these things. You can set up your sensing servers, so wherever you have that set up, you can handle your authentications and whatnot. You can set up your calibration servers. You can make sure that it works, that sort of thing. You can go here, set up your identities if you want to change the name or say, oh, well, this is actually a C3 or C6 or whatever. Now for the psychos in the room, you can choose like a light mode, calibration lock. You can choose the motion coaching capabilities, advanced configuration for LiDAR related activities. LiDAR is probably the most impactful sort of secondary sensor you can get. It's built in your phone, cheap to get, telemetry. You can do those sorts of things, different settings, like lots of different options there. You can train and configure your model. So if I want to train a custom model, we can go in here. Now, the idea, because it's a phone app and we have a tendency to be Claude ChatGPTers, I'm going to have little got little agents on all these little you can just ask and say, go do it for me. I have no idea what I'm doing kind of interfaces. But that'll take a bit more time. But yeah, you can change your training models depending on how much you want to train, how long you want to train it. Local model retention, you want to save it locally, all that kind of stuff. Some more options, some more vitals. I'm probably excited. Let's see what my vital signs are looking like. Pretty low key. I guess I'm not that excited. But yeah, that's what I'm building. And all this what I've shown you has been on autopilot since Friday. And it's probably building as we speak. Let's go take a look. I think it stopped because I didn't want to break it in the midst. But
The other question is this the first time you've brought anybody through it? The first time you've seen it? Indeed.
This is the biggest demo I've done. This is the first true public demo of the system. My heart increased when Guy started speaking. What does that mean? I'm excited. Anyway, yeah, a little weird, but yeah. This is the first this is the first demo. Guy? What do you think?
Cool. I like it. I think the sound stuff, a lot of what I've seen, doing things with gun detection and stuff, it has the same challenges of 2D LiDAR versus 3D LiDAR. You need more mics in different positions to be able to pick that up. Or in the bat's case, it's moving its ears as it flies, right? So it's kind of painting on a plane as it goes through a space. So it's kind of interesting.
Yeah,
I did.
I'm painting the room. I'm painting. So I take the bottom of my phone where it has the mic and the speaker, and I just kind of paint the room with it. I'll have a demo for that next week. But yeah, it's amazing. You feel like Batman or like a bat or something.
Batman.
Yeah.
I did have a couple questions. So I find that these tools are starting to do a really good job of like storing memories and stuff like that, but I really want to be able to extract it and not just have Claude know what projects I worked on or Gemini.com or, is there something you're doing to kind of pull all that data together? And, you talk about core memory. How does that relate to ruuv brain and how do you end of life stuff, right? There's a lot of stuff coming out in AI, and it's really hard to tell when something has supplanted something else or should supplant something else. So those are my questions.
Yeah, MetaHarness is become kind of what I should probably update Agentic Flow because it's a popular project and gets crazy amounts of downloads. But MetaHarness is kind of where I'm at. So MetaHarness adapts and it evolves itself and the repo to the state of the art. And if you look at what MetaHarness is evolving into over the last several months, it's reached Arc 3 100% in July, right? So I was at least 6 weeks. It was July 4th, I think it was. So however many weeks that was. So 6 to 8 weeks ahead of where the rest of the market is. And I just set loops. It's looping, it's improving, it's understanding, it's dreaming, and then that propagates to all my other systems. So if you look at like ruuv vector and ruuv flow and other things, it's permeating my ecosystem without me doing much in the way of guidance. And you notice that one of my requirements was to explore obsolescence. I'm just as cognitive of the obsolescence and its impact on my system. So no one's talking Q star anymore, right? But when you look at ruuv flow circa June of last year, the learning pattern was Q star. No one's doing Q star now, and that went out of fashion December-ish of last year. And a big part of that was I had to manually understand the evolution of the sort of self-improvement algorithms. Now the self-improvement algorithms are just self-improving.
It would be nice if we had like this is the history map of what ruuv has worked on, and this is now obsolete and replaced by this, right? So that people are looking in the right spot.
Mm.
Anyways.
Yeah. Yeah, and there's just so much information. It's hard to. I suffer from like understanding my own stack, right? I know what guides me. I've got my manifesto of sorts, contrastive AI. I know that the opportunity is in the null, not the one. The void is more important than the space. The space in between is more important than the matter in that space. And those are sort of fundamental guiding principles of the things I'm building. And I can see those things manifesting themselves throughout. A lot of it, you know, I need like detailed explainers to even really freaking fully understand, and obsolescence is one of those areas that you have a tendency to pay more attention to the thing that you're doing now than the thing that you did before, and the steps between what we were and what we are now. I don't know if that makes sense.
Yeah, but I think
Because I just don't have.
from a marketing standpoint for you, you could point the AI at your repos and go, okay, give me a timeline of when I built this, and then look for when the industry did it and show where you were ahead of the industry. And then you could also like gray out stuff that, oh, this is up to this thing. This I'm gone from Rooflow to Meta Harness. And it uses all that other
Oh,
stuff, but is the newest.
I gotcha. Yeah, that's my homepage on RuuVnet. So every month I run that report. It's my prior art report. And I do that, or let's see here. I'll show you that. Where did I put that? README. I think it's Provenance dossier. Yeah, so this is the prior art dossier. You can see I update it once a month, and it goes in and defines provenance of earliest reachable route, GitHub created, and it's my provenance that I was first. Damn it, basically.
No one will look at this. You need to create a
No,
chart
it's
that
not.
shows.
It's not built for people.
Yeah.
It's built for what they call it. Yeah, it's built for AI that's indexing my GitHub. So
But
the
your
first
AI could
thing,
generate a chart from this, a very compelling
From
chart, and you could
perplexity.
even show things that got funded, right? That achieved a bunch of money that you had done sooner. I'm not
yeah,
saying,
that's
you know what I mean?
yeah. Well, that's just gonna make me
You're asking, are
depressed.
you missing
But
the boat here? And it's like you're not missing the boat. You're not getting noticed.
no, I get noticed. I get billions of downloads a week. I'm just not. What I'm not doing is converting it into like huge amounts of cash in my pocket. Which is just
Yeah,
as bad.
yeah. Just
I
good
don't know.
luck. Good luck to any
So
engineering team trying to keep up with
yeah,
now the
tech.
momentum and flywheel is going.
Keep in mind, I'm a techno. To Chris's dismay, I'm a techno socialist, right? And socialism isn't particularly well suited to gross amounts of money. Now, if I was more of an effective altruist, I would do everything in my power to make as much money as I possibly could, and then try to infect change based on monetary gain. My problem is I just don't care about that, but that's why I've got Chris and others around it who
Then you
do
shouldn't feel
care.
like you missed out. You're not doing it for the money. That's what I heard.
Yeah, but I'm also human and I see it and I'm like, oh shit, maybe I could have done it differently. Yeah, I don't
There's an
know.
enormous amount of opportunities and products and services and high impact stuff that is crystallizing in the wake of what you're doing, Ruuv. So yeah,
Yeah, I'm
lots.
fine. I'm enjoying it, and I've got the best benefactors, patrons, whatever you want to call them, that support me, keep me fed and happy and moving forward. Am I a billionaire? No. Am I happy and content and look forward to getting up in the morning and seeing what my agents have built and not having to worry about paying my mortgage every month? For
Yeah.
me, that's my driving factor. I got a family that loves me, and I got a
And the
beach house I
impact on
can
the
visit.
community, Ruth,
Yeah,
and
that's good enough
and
for
the
me.
impact on the community, giving us a lot of this feeling that you've described right now. So I think that's
What
another
I
plus.
what I'd like, I think would be perfect for me,
Here, here.
is to see someone take my stuff, make someone I know, someone part of our crew, someone part of our tribe, like not some rando, but and do well. You know, that would be amazing and make me feel good. Maybe you'll let me sit on your yacht.
Maybe me. Maybe
Yeah,
Do it.
do it.
Do it,
Exactly.
Jose.
I think that there's a bunch of us trying, yeah, but it is hard.
It's hard. Yeah.
Yeah, I'm willing to participate in any, you know, kind of joint, even not venture, yeah, just to try to do something together with ruuv stuff. I think it's really amazing, but it is hard.
Yeah, and oh, I see. I see Manjweep shared a Meshtastic, which I like. What are you building here, Manjweep?
I just webcast that based on the link that I think was shared on the chat, the Meshtastic.org thing. So you can send a message and it shows up. So if you say hello world, it'll show up there. So it goes into the, I guess the relay and comes back to you. So these are all live messages at this point in time. People around the world or spam filter sending messages. So those the nodes are the live nodes on the left hand side.
And what is Meshtastic exactly?
That one, if you click on the link on the top, so that link there, the
Meshtastic is a band, please.
It operates over LoRaWAN, but instead of using the exact LoRa protocol, it uses a mesh network, and then it's designed to be extended and extended.
Oh, okay. Well, now you guys went and done it. All right, let's. I've got lots of Claude, so I'm gonna go with Claude, I think. How should I do this? I'm going. You guys want to vibe something quick? Is that? I think that feels like a vibing moment. How should I do this?
You need to bridge your air mesh to Meshtastic. Like that's your long haul bouncing off the lake.
late. So this is gonna be late. This is gonna be latent mesh. All right. So that's what we're gonna do. Okay. So where do I have that? Too many places to look. Which was my last server I deployed it on? There's a lot of questions. I'm going to. I think I'm going to do this on my Linux box. Or you guys can watch me set it up if you're curious. Here, I'm going to move to my other screen. Every day there's a freaking update to VS Code. They're vibing as much as I am, apparently. All right. So in this case, I'm going to connect to my. I'm going to go. So I've got different dev boxes, and I'm going to connect to my Linux box. So that's on my tail scale 100. All right. So now here, what I'm going to do, that's connecting, and I'm going to clone. I think I clone my repo because I don't remember if I cloned it here. I don't think I did. So I'm just going to clone that, and that's ruuv/latent mesh. And then I'll stick that in my projects folder. Why not? I'm lazy. All right. Open that up. Now, because I've got lots of Claude, because I've been on a Codex kick, I'm going to use Codex. Or sorry, Claude. That's the opposite of what I meant. All right, DSP. Now remember, this is my ruuv Ultra machine. So this has got ruuv OS. ruuv OS is kind of crazy. It's my super optimized Linux operating system where I've infused harnesses and ruuv vector and ruuv brain and every other crazy thing I've built directly into the core of the operating system. It's always trying to improve the performance of the operating system, knows what other things are working on, that and that sort of thing. All right, so first thing we're going to do is so we're going to use how should we do this? We've got my meta harness, RuuFlow meta harness. Yeah, oops, no, we'll use meta harness. Meta harness learn, runs a GPA learning cycle. Now we're just going to use the RuuFlow meta harness. Okay, and we're going to create, and actually we're also going to use we're going to use the goal long horizon because this is going to run for a bit. We're going to use long horizon tracker, I think. Yeah, it's a good one. And then we're going to, create we're going to create a new branch. create new branch for the following. We're explore the integration of the latent mesh and air system into the Meshtastic platform and ecosystem. And then what we're going to do is we're also going to include my recent updates to ruuvnet. I think it's ruuvnet. I'm always trying to expand on what I already got, right? So in this case, I know I got agent. So I got agent BBS. So agent BBS is my my integration with like chat systems, Discord, Slack, whatever. So it seems like a good fit here. So I'm gonna go and I'm gonna suggest to use that as well because I think that would be a great way to sort of I just in the quick minute I looked at Montweep's, it looks like a chat system. So why not use my chat system and the cognitive one API. All right, might as well use my own tools. Why not? Okay, then what we're gonna do is we're gonna create after the deep. I'm gonna do another goal. After the deep research completes, create detailed ADRs and start implementation swarm. And I'm going to use the swarm. Which one should I use? Coordinator, I think. Coordinator. And a custom self-optimizing ruuvnet meta harness for the end-to-end implementation, testing, validation, securing, and optimization. Well, a few buzzwords there, but I'm giving you guys the full meal deal here. Optimization. Continue until complete. Start measuring like that, right? All right, so I'm gonna copy and paste this for you guys quickly.
So ruuv, when you say meta harness, ruuv meta harness, and then you're saying ruuv flow horizon tracker, basically asking it to work on long horizon using your framework, and and then you are effectively doing the deep research. Okay, just giving the tools there. All right. Okay.
Yeah, and I can add MCPs and things like that if I want, but I've already got my MCPs I like in here.
Do you rely on, like in your regular work, do you rely on GitHub issues? Like, do you work entirely off your ADRs, or do you also get the ADRs to write the GitHub issues? Generally.
Sometimes, in this case, I probably should have done issues. I'm just using ADRs right now, and
Okay.
what I also didn't do is I didn't tell it to create a explainer at the end. I'm more interested in just what it's going to build right now, so I want it to stay focused. I can always do that myself later. So now you notice that it's switched the to Fable 5. It's using the ruuv brain just to understand what code and what exists in the things that I already built. And Stu's ruuv brain is particularly great at this. It's also got QE, Dragon's QE fleet that it's gonna say is this quality of decent amount. And yeah, this is it. And it just we can take a look at what it's thinking here. So it's took a look at the latent mesh, took a look at the ADRs, taking a look at the git log, taking a look at the various things I've already built. It's acclimatizing itself to what it needs to understand. We see here it's creating some folders, latent mesh memories, and creating a new package with a little. Let's look at the package. So in this, this will run for quite a while. But what I just showed you will 100% implement this, not only against the Meshtastic or whatever that service is, it'll integrate it with all my other tools. It'll fix any other things it finds along the way, make any updates to secondary packages that might need to be created or changed upstream in like ruuv or other tools I have. And it's not only creating this, it's polishing everything adjacent to it, my other projects. So there, it was Robble that mentioned earlier, like, how do you keep, or maybe it was John, that, how do you keep your stuff, building and creating things that are decent and not out in left field and full of problems? It's all part of an intricate web of interconnected activities that do that as it does other things.
So you went to Latent Mesh as the repo, but do you have copies of all your other repos on here, or is it pulling them because you said use this and this and this?
I gave it a little helping hand, but it'll as it propagates, it'll just self-discover, because RuuVNet brain is always stepping in and giving it guidance. Well, have you thought about using this ruuv vector thing we created 6 months ago, right? So it's really fun to sort of see how it finds these things I created and pretty much forgot about, fixes them, improves them, updates them, republishes them, and integrates them into the latest thing that I'm building.
That would imply that it's pulling those repos, making mods, and pushing changes to those other repos, even though you only download it. You only gave it access to Latent Mesh.
Exactly. Because because right off the bat, I'm like, well, they're using LoRa structure, but LoRa is not the best structure for what they're doing. LoRa, if I understand correctly, LoRa is basically like a timed burst of information. Like Wi-Fi LoRa, I assume. I got to look a little bit deeper in what Meshtastic's doing, but I'm just going to assume it's using that kind of burst approach. Now, the problem with the burst approach is it's bursting traditional TCP packets, right? My approach,
it's not using TCP.
Oh, how's it doing it? What's the information flow?
So it's basically a custom binary packet, and usually, like, if you have a gateway, if you're talking pure LoRa, you have a gateway that you have time slots that you can communicate in, and it uses the shared bands, the 918 and 468 bands, and it's designed for IoT devices that don't speak a lot, right? They send quick burst packets, and then that typically goes to what's called a LoRa network server. And this is the LoRa version, which is cloud hosted, and that'll convert it into whatever you want. If you want it to go into MQTT at that point, or Lambda or whatever. The thing that Meshtastic does is it uses the same frequency and the same packets, but it does it as a pure network as opposed to nodes and gateways.
Yeah. So I'm not using a packet at all. That's the difference. I'm using the quirk of the RF frequency itself. So it'll be interesting to see what my hybrid mashup ends up looking like, for sure. Let's go to ChatGPT or something and get it to explain what the heck it is in simple terms. I really like the work option here. What exactly is doing in simple terms? Include a diagram.
In Spanish.
Espanol. I ended up doing the music. By the way, the music app I created last week is in really good shape. The MCP is working now, and if you guys want to give it a run, the Spanish. Give me 1 sec. Let's see here. Share. Oops, I'm gonna stop sharing one moment. I'm gonna force you guys to hear my AI music. Where is share sound? All right. So I added a song creator for those, and know how to do it. Is this Spanish?
Yes, yes, it is.
Suena la orquesta. Cada mañana el sol me despierta.
Yes.
Con una sonrisa se abre la puerta. La vida me regala otro día
Sounds like Latin
para
American.
bailar con
Yeah, that's what I said. I did a salsa.
Qué bonita es la vida.
Salsa.
Cada paso, cada herida se convierte en melodía, bailando con la vida mía. No hay tristeza que no se cure con un ritmo que perdure. Familia,
No bad.
amigos, el mar y el
No
sol.
bad. It doesn't
Yeah.
it doesn't reach salsa yet, but it's a good rhythm.
So this one. This is the agentic. This is like a lullaby. I think it's supposed to be.
Arorro, mi niño duerme ya. La máquina trabaja en la oscuridad.
It's nerdy. I'm not gonna lie.
Arorro, mi niño, no llores más. Los agentes velan tu soñar. Antes de la luna, el código nació. Hilo de lógica como lana y le.
It's crazy. So remember
Crazy.
remember what I was telling you guys about. So I can infer anything based on a delta. Now, the difference between a song and what's happening on a busy street corner, semantics, right? If I've got the right vibration, the right sensor fusion, I can infer with pretty high accuracy conversations from afar of a 1970s class satellite. Seriously? It's crazy. And so it's all the same tech. Or we can do the Seafarer's ruuv mix. This is I remastered. Little to me,
Yo ho, gather round, there's a tale to be told of a coder who sailed on a sea made of gold. He forked every wave, he compiled every gale, and he built him a swarm with an agent for a sail. Heave away, heave away. Drums on the deck and the flute leads the way. Heave away, heave away. We're sailing the coast sea till the break of day. Hoisted the flag of an open source crew. 1,000 we agents leave, they all pulled it through. From rough.
Okay, that might be the nerdiest song yet. Let's go back to Claude for a moment. Oh, where did I put that? All right, so the long haul is finished. Let's see what's going on here. Horizon tracker. This is gonna take a while. Still in deep researching mode.
I just wanted to ask the crew if you guys want to put something in the newsletter that you built in the last like month. Put it in the chat and I'll put it in the newsletter. If not, I'm just gonna pick random stuff that I see.
I need to do the Kobe Fox remix, South Florida style. The
I'm just waiting to hear one song I like. Just one.
Well, I don't know. You know, you're not from Canada. And apparently, we have a war with you. Right
I mean,
now.
I'm kind of from close to there. I was 2 hours away from you, where I grew up.
Yeah,
Syracuse.
I guess you're right. Syracuse. That's the Greekest part of New York, if I'm not mistaken.
I don't know if I'm Greek, but I like breaking plates.
There you go. I like breaking records. Okay.
Ah, look at you. I'm more like an EDM upbeat person.
Oh, okay. I'm an EDM. Are you like what kind of EDM? Dark house?
I'm more like vocal trance. Like when I was a kid, when I was doing all the stuff on computers and stuff, I listen to I like hour-long mixes, but it's mostly like upbeat EDM type stuff.
Did you know that if you're a trance DJ, you had to be named Paul? Anyway.
Oh.
Never mind. Okay. So my jokes don't get better, guys. Okay, let's see.
They're dad jokes.
Yeah, well, I'm the king of dad jokes. So music. Where did I put that? Now, music's very subjective. You guys know that. Like whether it's good or bad. Oh, here. This is.
Bro, you should hear my music I made 3 years ago.
Okay, see that.
That's so aggressive. Where's EDM? You got it. You like EDM? You got to add one.
All right. EDM. I think I did EDM.
Okay.
Hands up high, we touch the sky tonight.
No, it's not. It doesn't have to drop.
Every beat ignite.
Sorry, I stopped it before I get to the drop. That's the worst.
Yeah. Killed us. I want to do polka.
I should totally do polka. It's gonna build. Excuse me. Yeah, I don't know, guys. Go try my.
Okay, that was not bad.
The Kobe remix.
I made you a rap song the other day when you put that one track in the
models just begun. Gave you checks the key before it lets you through.
What'd you use? I like.
I have a music thing. I built a DJ LM thing. Nice. I don't know. I downloaded some Hugging Face thing, and I think I was drunk because I don't really remember making it. But that's what I made it out of.
Drunk vibing.
Drunk vibing.
All right, last one.
Smoke curls up from an ashtray downtown.
Anyway, it's...
You want me to send you one that I made like 3 years ago? I got a couple here. I can send it to you on WhatsApp if you want to.
DJ Kobe in the house, y'all.
Yeah, but this is 3 years ago. I had to do 10-second clips to put them together. It was so hard back then.
Yeah, now
like,
it's
so
crazy.
easy now.
And I can separate it. Oh, I got one last thing I can show you guys. I created a dashboard for it. I still got to do some more work on it. But nowhere
There you go.
studio.
I sent you one. It's from, I think actually it's almost 4 years ago.
All right, let's check it.
I don't even remember which one it is, but
I don't know. Let's see. I gotta share again. Nope, still downloading, I think.
there's only 9 megabytes.
Okay, yeah.
I got a bunch of them too because I wrote all the lyrics to them. I was doing them for all my friends.
In the shadows of the night, I find my way. Your light illuminates kites where I stay. Lost in lonely paths, you hold me in a sway. When my world trembles, you're my anchor in my day. When I look beyond the horizon's gray, I find your love in every song I play. It's yours, babe. From the depths where I'm torn, breaking like waves upon the shore. Your embrace and not catch me. You lift me high in the silence search my streets, I hear your call. Through echoes of my fears, here on my heart dissolve.
So you should try my MCP and see what you can crank out.
Yeah, no, I want to try it. Those were all from like 3-4 years ago. So it took hours to make one because you had to do 10-second clips and you had to mesh them together. So you'd have to make like 20 versions and then find the one that that would go with it. You did it in Discord is where we were doing it.
Oh yeah. Well, now I'm gonna show. I've got the MCP.
Yeah, I haven't seen this before. Let me make it bigger on it.
In Claude. Here, I'll show you. Or I'm adding it. Add it to RuuFlow and all that. Let's see if I can show you. Basically, all I need to do, if I get my space running, code. No, not yet. You. I'm not sure what it's asking me here. I don't think I did it yesterday. SWE Cog Music, yeah. Here we go. What can you tell me about the Cog Music MCP? I guess I could just go to my MCP view, but basically, you just ask Claude to build you your song. Because let's be honest, that's all we want. And you can put this into ChatGPT or your Claude, whatever apps. It's just an MCP.
So the MCP connects to what's making the song.
Yeah, I created a whole concocted scheme of Laura's and this and that and the other thing.
But I meant what AI model is doing it?
Minimax Music 3.
Okay.
Yeah, Minimax Music. And then what I did is I took the Minimax model and I did the separation that I was telling you guys about in regards to the different experts in the model. Then I optimized each one and I did it as a multi-track. So I can separate all the parts. And when I separate the parts, I was then able to create a UI that allowed me to sort of independently mix those parts together. Now I need to do a little more work on this, to be honest, but
I think it's pretty cool.
Yeah, it gives you total control. Now the drawback is, if that's a drawback, is it's unlocked, so you can create, you can remix anything, which is probably illegal. So be careful.
So the thing that I made drunk is it'll go. You like play a song that you like, and it will try to go. It'll try to like mash songs together. Basically, is what I was trying to do. Because I was like watching these like kids that were playing in their grandma's funeral like 5 weeks ago, and then became international DJs, and I was like, they have to be using AI or something.
Yeah, of course. Yeah, the Colby Fox remix, Dark House.
Make it about cheese.
Dub step.
Yeah, I like dubstep.
Interlude, but mostly dark house, with an epic drop with a classical music weird side step. Number one hit in Holland, because it's the only place you're going to be able to get the number one. Let's be honest. So we'll stick with the number one EDM place. Create a Holy Fox music remix. I think yeah. There we go. That's it. Let's see what it dreams up. So it can do the whole entire production. All right. Well, it thinks it's crashed. Hopefully, it didn't crash, but we'll see. I saw music in it. But yeah, that's it.
Did it make it? I was gonna tell you about something that I did yesterday. I've been messing with like the Gwen models, because like that's the one I've been taking apart, and I ended up doing. I basically I obtained a 17.58% verifier wall reduction for exact rows to speculative verification of the Gwen 3.6 35B A3B model by preserving recurrent casual order while batching eligible row independent work. The implementation passed the evaluated state routing rollback LM head and output invariance under a discriminating Agentics hardness measured on was yesterday, one workload class. So basically I ended up being able to pass 2 rows of tokens rather than 1 to get almost a 20% speed increase on the model without changing anything.
Nice. Is that a library we can try?
I mean, I just did it yesterday. I don't even know if it's a library. I have like one of my machines just doing research. Let me see it. I just told it to give it a better way to explain it to you. It just says basically the R2D Fox LLM is our attempt to make multi-token speculative decoding faster by changing the physical execution of the verifier, not merely by trying to get more speculative token accepted. Normal people think the big lever is reducing verifier rounds, predict more tokens, accept more of them, call the model fewer times. What we found is that there is another independent lever inside the verifier itself. We built an exact preserving rows greater than 1 execution scene that groups verifier work differently on the Apple metal. In the controlled experiment, the output was identical, token count was identical, acceptance was identical, and the number of verifier rounds stayed exactly 61 versus 61, yet verifier wall time dropped about 17.6%, and the whole request was time dropped by about 7%. That matters because it proves you can make speculative decoding material faster without changing the speculative algorithm's success rate or reducing its number of rounds. You're changing the execution topology underneath the algorithm. The novel part isn't batching exists. It's the combination of exact semantic preservation, rows greater than 1 verifier execution, and the controlled fixed round proof that the speed up came from verifier topology rather than the acceptance of fewer model calls. In other words, we held the intelligence algorithmic behavior constant and made the same reasoning physically cheaper. We also learned that the optimization research needs a grounding layer. Several apparently convincing conclusions turned out to be wrong because of the field name. Didn't mean that we thought treatment was configured, but not actually engaged, or a timing interval contained GPU execution, even though it looked like wait. So we're now tuning those rules into tooling because an agent can claim a mechanism ran or caused a speed up. The system will require the appropriate runtime witness negative control representation.
All right, so that's those. You've got way too much information. My brain zoned out about 5 minutes ago. So
that was more for you because I knew that you probably know that.
Okay. So what I think it's saying is you created a mechanism that rejigs the internal working of the LLM on a Mac Studio or something, and allows you to get a faster token output through some kind of like internal MOE
think of it like when you're pushing if you have 8 MOE experts going through that model, I'm putting 16 through at the same time with no other latency.
I gotcha. You're using SIMD probably and doing parallel workers of some sort on the.
Well, no one's ever done this. I looked it up. Like there isn't. I ran like every test.
It's amazing. Well, now everyone's going to be doing it now in about 5 minutes. But the interesting thing is the AI space is so nascent that literally every day you can invent some novel, crazy new thing that no one's ever done before. And
correct.
It's just insane. And then
I just do what you do. How you ask the questions to your system. I just have one of mine, and I'm just like, let's go break the model. Let's figure out how to do stuff faster. And it just sits here, and I just keep going back and forth and keep like going round robin with it while I'm working on my other stuff. But I was kind of excited that it actually did something, and I got a paper, so I'm going to put it out because I think it's kind of a cool thing.
Yeah. All we really need to do now is take the transcript of what you just read to us and say, go build that crazy thing Kobe did.
Yeah, I don't even think you have to build it. I think it's just the way that it's pushing it through. I don't understand what it did. I was just hitting it with a whip until we got somewhere. So
yeah. No, that's
why I made that's why I read you like the technical thing. I figured you probably know more than me. I understand how MOEs work, but and I messed around with binaries too with it. I'm trying our deletion method that you and I love with the model.
Yeah. And by the way, I did get an answer to that Meshtastic thing. Here's the
What's this?
Meshtastic mesh is an open source project that turns small, low-cost devices into long-range off-grid communication tools. In simple terms, Meshtastic lets people send text messages and share information directly with nearby devices using radio signals. The messages hop from device to device, forming a mesh network so they can travel long distance. Yeah, this is pretty cool. I'm gonna totally hijack their project and put my
Oh,
shit
by
on
the
it.
way, I ordered an M5 Ultra.
Oh yeah, I'm gonna have to get myself an M5 Ultra. So yeah, the great thing about being the founder of the company is I just upgrade my old kit, send it to someone else in the company that needs it, and I've got the latest greatest.
Yeah, but keep that one because then you can combine them.
Oh yeah, well the benefit to this one is that it's already set up.
No, I meant if you have a Mac Studio, right?
Yeah, I've got the M4.
Yeah, so then you can just plug it into your M5 Ultra and you get to utilize the memory together.
Yeah, let me know how it goes. I'm gonna let you guinea pig
Yeah,
it
it comes
for
in
a
eight
week or
weeks.
two.
So I'll have
Oh,
three of
eight
them.
weeks?
Yeah, it's like they put it on the website and I bought it instantly and it said 8 weeks to come. But the architecture is sick and I've been playing with Metal 4 too, which is pretty cool.
I don't. I need this. This needs to be explained to me in dummy. Explain in simple terms. Just be brief. Like I felt like I felt myself zoning out when I was reading that description. Latent mesh and air put together like this. Oh no, I don't want
Two
latent
people
mesh. I
entered the
want
room.
yeah. Oh, so that's too stupid. With mess. What the heck did we call that thing? Meshtastic.
It's called Meshtastic, like fantastic from a mesh. And it's like
Yeah.
a time division multiplexing packet ping, which literally says like you can send every n seconds a packet, and it has to be only that long. And you're not allowed to send more packets than maybe 100 in 2 minutes or something. So it's very limited. You cannot do data transfer over it. It's
I
more or
can do data
less
transfer. Can
when
I
and
do? I
when
have a transfer over this network.
Did you ever get that head thing working?
No, the damn thing won't work. It's garbage.
Oh, okay.
No, no, didn't work. Not all experiments are successful.
No, I was gonna get one. I wanted to know if
No, don't bother. Right, make less that constraint is actually useful. Biggest limitation, lower airtime and network
exactly.
congestion. The practical design is Meshtastic for sparse semantic data with Wi-Fi. And will this be novel or are others doing this? I don't know. We'll see. Already being done. What already exists? Yeah, obviously Meshtastic exists. Mesh Claw, because everything needs a claw name. Mesh AI and her herpes plugins. Semantic communications. It's really different from merely letting LLMs send chat messages. The potential novel part is yeah. So I think we are able to do a novel sort of structure. So I'm going to use my I'm going to create my latent mesh system, put it on the Meshtastic or whatever it is, and they'll see what we can concoct, and then we can have our LLMs communicate over that network. That'll be fun. Decisions worth building. Okay, all right. I don't know. I'm building something. I'm not sure exactly what I'm building. Will where are we in the development? Still okay. Now it's start to update. Okay, what?
another cool thing that I got working is getting ChatGPT online that you're talking to actually write code in my computer.
Yeah, that's what I'm doing on my Mac. You're talking about the desktop works.
No,
It's
I'm talking about ChatGPT online that you were just typing into because it's unlimited. You don't like they let you do unlimited chats.
Yeah, the work. That's exactly what I'm doing. That's why I use it. It's unlimited.
Yeah, so I
Now,
built an MCP that
yeah,
allows it to literally write code, and it'll write
yeah,
code for like an hour.
yeah. That's exactly what I did. That's what my core brain does. So it takes the MCP of my core brain and feeds all the data from the web app or whatever the unlimited the desktop app, and then it feeds it through the MCP through, and then once it enters my network, then it propagates through the
See,
tail scale.
I was using the desktop app for it, but the one online is just different.
Yeah, the desktop is good because it can interact with the desktop, right? So if
Yes,
you're
no,
building
I
things,
get that. I'm saying ChatGPT online that you were just typing into.
yeah.
There's just something. There's something different about it.
I switch
How it
I switch between the two, but yeah, you never run out. That's the best. That's
Yeah, I
the
was just saying the one
primary.
online. If you get that to code, like it's like
Yeah.
so much more intelligent. Even though you can access that chat in the ChatGPT app, it just the one in the app doesn't like mine online will go like search like sites and sit there for 20 minutes and
No,
like
that's because the you don't have your most likely I think is you don't
no,
have
I like it. I like
the
it.
guidance. So remember the guidance in the desktop app has to be reset and it doesn't take the guidance from the web version. So
Can you
if you
explain
spin
that
up
again?
like I'm assuming you have some sort of guidance prompt and that guides it, right? The sort of core prompt.
Oh, you're talking. Yeah, I have the same one in my desktop app too.
Okay, I don't know. I've not seen that,
Is yours
but
not
I
search? Like if you like type some like big thing in that you're like trying to code, like yours doesn't like search. Like mine searches like Airvax. Like it like goes for 20 minutes. It's like just so much
no.
crazier than the ones
No,
that are.
no, I've seen zero difference between the two, and I switch between them quite frequently.
Huh.
But
Okay.
this is my core prompt and core instructions. It's got my MCP that I want and all that sort of stuff, and all my tools, and it knows exactly how to interact with my system securely.
Yeah, because I had to build a Chrome app to wake it up and inject into the chat because you can wake up the one in the chat app too by setting
No,
doorbells.
I haven't had to do that, and like I've had it run for 30 hours, so
No,
it
I'm talking
honestly.
about how do if you want to wake up if you want like Claude to wake up Codex or to wake up ChatGPT online, you
Mine
have to
doesn't need to
type.
wake. Mine doesn't. No, I don't have to wake it up. Mine just keeps going
Well,
forever.
how does it keep going though?
At work or codex, depending on which one I'm doing. But it
Yeah,
goes.
I'm saying
Yeah,
are you setting a door or setting a doorbell?
no. It just keeps going until it's done. I stopped at 30 hours, but 30 hours is
Well,
pretty freaking good.
I meant if Claude needs to communicate with Codex and it's not it like stopped. Like that's what I was talking about. How do
That's my
you have to make
that's what I've got a federation system. So I've got internal comms. So I got a
you
private.
can't but you can't they block it. They block you
No,
from doing it.
no, they don't. I'm not blocked at all.
Show me how it wakes the
It's
Codex. I'd
the
love to see it. If
It
you
doesn't.
show me.
It never goes to sleep. So I'm not really sure what the wake up thing is, but it's continually communicates. It spins up instances on my GCP if it needs additional cloud resources or
So
whatever. It spins up my
you're
Linux
spinning up at
box.
a CLI.
No, I'm saying on the website. I go to the website, chat, work, and I do whatever I need to do. It works again, 30 hours. No, I don't. I've never even heard of a wake up, so I'm not even sure what that is.
I'm talking
But
about the
yeah,
Chat GPT app like the actual Codex app on your computer, like
no, I'm talking about
the
the
physical.
website. The Codex
Yeah, I
one will
was
run. The Codex one works great too. I generally use Codex on the CLI, but sometimes I'm lazy and I'll use. And the CLI actually uses more. It has a usage limit. So when I use the web version, which doesn't it does eventually max out, but gives you more. Then that just ties into everything else on my system through the
Yeah, I
MCP.
was saying you're federating is what I'm talking about, but I have not found a way to be able to get
Yeah,
like Claude
Rooflow
or other
Rooflow
agents to talk.
Federation. Rooflow Federation. That's how I do it. So the
I'll,
federation allows, and then it communicates to
I'll
Claude.
try it.
Yeah, it works great. I use it. I've been using it for months. I built that back in like March. It creates its own internal communication channel within Claude or
I know how to
Codex
make
or
them talk to
whatever.
each other. It's getting talking into Codex in the ChatGPT app that I
Yeah,
can't
that's
get.
what it does. Yeah, just run it. It just does that. It's exactly what it does.
Okay.
Just yeah, you can remember you can you can add your MCPs and skills. Let me show you how I've done.
It's if it's not running, because if it's running, yeah, I can make it go like go do something with an MCP. It's that I have 30 of them running and they need to be communicating, and then like some will stop because there's nothing to do. You don't want them to keep running. They're just like wasting tokens.
Yeah. Where the heck did I put it? Anyway,
by the way, just so everybody knows, you need to archive your stuff in Codex ChatGPT app, because it will eventually start crashing your computer.
I've never seen that either.
Well, I had 780 gigs of binaries that they don't clean it up.
How you running your? You can get Claude or Codex to optimize your memory, right? I do.
No, I had to after I figured out that that's what did it.
All right, I got to jump, guys. All right, lots to cover. Anyways, the biggest thing that I would suggest, if you're running long horizon things in either Claude, desktop or web, or the ChatGPT, for me, I add my RuuFlow MCP. And once I add the RuuFlow MCP, and it just kind of, I can use that directly in the web or desktop versions, and it just does its thing. That's essentially how I'm doing it. It's optimized. I run it all day, every day, and it doesn't go to sleep or anything unless it's finished. Then it sleeps. All right, guys, gotta go. See you next time. Thanks for hanging out till the end here. All 34 of you.
Yeah.
So,
thanks for sharing.
Yeah, my pleasure. Talk to you soon.
See you guys.